Hello, everyone. I am Fei Zhang, and I'm glad to introduce this text-to-3D platform. This demo is a technical demonstration of text-to-3D Mechanical CAD Explorer, which is a working MVP that turns design intent into editable CAD artifacts. Next, I will introduce the purpose of this demonstration. So this demo documents the current technical progress of text-to-3D as a working public MVP, so which includes a working browser prototype, the public live demo, the open source repository, the CAD generation pipeline, the downloadable artifacts, and roadmap foundations. So next, I will introduce problem and motivation. So mechanical design begins with intent, but the traditional CAD workflow often require expert level tuning before a user can explore an idea. So the problem like high tuning barrier, slow early iteration, access gap, and then the mesh versus CAD gap. So the traditional workflow usually begins with the user idea to CAD training and then manually modeling and finally get the export models. But with the text to 3D direction, so we from the design intent directly go to AI assisted generation and we get editable CAD artifacts. So the proposed solution is text to 3D let users express mechanical design intent through conversation and produce downloadable CAD outputs. The procedure is start from conversational input and then go through the AI plus backend orchestration, and then we get CAD artifacts. So the current MVP includes prompt input, the 3D preview, the CAD execution, and the downloads. The next stage, we will have the image input, the model validation, the repair loops, and user workspace. The long-term vision will be to build an accessible AI-assisted mechanical design workflow. Platform overview. So this platform could be divided into 4 parts. Part 1 is user interface. This includes an Angular frontend. So there's a chat panel, the 3 and 3.js model viewer. The second part is backend orchestration. So we have the fast API conversations, plus job events, plus artifacts. And the part 3 is the AI large language model layer. So we have the provider adapters, which includes all different kind of model of providers. And the part 4 is the CAD execution layer. So we have the CAD query runner, the free CAD runner, and then the output format of step, GLB, STL, etc. So now I will give a live demo flow. First, refresh, go to this nitotrinet.com website, and then here we input the prompt, make a 40 millimeter cube with a 10 millimeter through hole. Generate. So you can see this is a workflow of step by step in the backend how to generate the, oh, okay, see the screenshot of the model and pass on to the large language model. And once it complete, okay, so the chat box will show the general result, and we have this model. We want to modify the model. to make the whole diameter a little bit larger, like to 25 millimeter. Okay, so we generate again. Okay, we can see the feedback of the drawing image. Okay, done. So we can see the model got updated. We can check the model, and also now we have the artifact. We can click and download here. So yeah, we can download the script and nodes. And this is the nodes include all the information. Yeah, that's all for this live demo. Here's the high-level architecture. So the flow is the user intent goes to structure response plus the cat code, and then the runner execution, and finally the downloadable cat artifacts. So from the block, we can see way from the user browser and then via the REST API, the WebSocket, it goes to the fast API backend. And then the API will via the provider adapter, so calling the large language model provider. And this provider will generate the CAD script. Then the CAD script goes as an artifact. So it goes to the CAD runner, and it will output the artifact of the 3D CAD models. Next is the backend technology. So we have the fast API service, which includes the REST endpoint for conversation, message, jobs, events, and artifacts. We have the SQLite MVP storage. So this is the local persistent for conversations, generation states, and events. We have the file system artifacts. So this includes the generated CAD files stored in the local data folder. We have the background jobs, so which are the long blocking generation workflow with status tracking. We have the provider adapters. So we have the mock, the commercial, slash, or open compatible large language model service integration. And finally, we have the WebSocket updates, so which has the live progress event streamed back to the front end. CAD generation pipeline. So we start from prompt. So the user submits design requirements, and then we go to store. So backend stores message and creates jobs, and then we generate. So large language model returns structured JSON plus CAD code, and then we validate. So the backend checks generated code and execute. The runner executes script in sub-process, and then we export. So all these models and the script and the logs we export. And finally, in the UI, we preview. So the front end knows generated 3D models. So the key technical point for this is the system demonstrates a complete path from natural language intent to downloadable CAD artifacts. And why use script-based CAD? So the script execution preserves parametric logic and enables future iteration editing. So previously we talked about the CAD generation pipeline, and now we are talking about the free CAD agent mode. The FreeCAD agent mode points towards an iteratively workflow, so where AI can create, inspect, revise, and export a live CAD document. So the backend has an agent host, so it can plan and call CAD tools. So all these create document, execute code, get objects, get view, export models, all these CAD tools. And then the free CAD workers is able to keep the live documents open and to support these tools. And also we have the browser UI to stream the events and view the dynamic updates. Front-end technology. So we have number one, the Angular standalone app. So the front end is using Angular to build the modular front-end implementation. And then for the front end, we have the chat-based design UI. So the user could communicate design intent in natural language. And we have the 3.js CAD preview. So the user could interactive view for generated models. And also we have the artifacts panel. So the user could download output for downstream tools. Next, I will introduce the open source and public accessibility of this platform. So text-to-3D is intended to be publicly inspectable and extensible rather than locked inside one private deployment. So you can find the public repository and source code available at github.com/zqf, this kind of URL. And this is the MIT license gave the maximum permission for people to utilize and modification and experimentation. And also the modular design includes the front end, the back end, the runners, the provider adapters, and the document that can evolve independently. So this is a screenshot view of this platform, and it's already been published publicly, so everyone could access and reference to the code and review and utilize. So why public access matters? It is because the open source publication supports independent review and educational use and community experimentation, and also a pathway to broader dissemination. Scope and responsible limitations. So this prototype is presented as an early MVP, so not a finished industrial CAD or production manufacturing system. So like the code checks, the step process runners, the timeout control, and the backend side keys. So all these are not production level done yet. So the current limitation is it's only single user and the local MVP scope, and it's not yet hardened the multi-tenant sandbox. And the authentication and permission are not done yet. They are future work. And the simulation and the manufacturing checks so remain on the roadmap items. So they are in a future plan and not done yet. And also the human engineering review remain necessary. Roadmap towards engineering grade capability will be the first. Now we have the MVP. So we have the prompt to CAD generation, the set 3D preview, and artifacts download, and documentation plus the public demo. And in the near term, so we will have a richer prompt and more CAD template, better validation, and the free CAD agent reliability. In the midterm, so we will have the image guided input, the CAD repair loops, the constraint aware edits, and the user workspace. So in the long term, we will do the simulation feedback, the manufacturability check, the educational pilots, and open source community. So how this MVP implements the platform vision. So the current text-to-3D MVP implements the first working stage of the broader AI assistant mechanical CAD platform. So we have the conversational design, the CAD script generation, the browser preview, artifact export, the open source base, and also the roadmap foundation. So all these factors indicate that this MVP already implement the platform vision. Finally, as a summary, what this demonstration shows. So first, we show the working public demo. So we show the platform can be accessed and operate in a browser. So we show the functional UI. So it can chat, preview, and then the artifact links are visible. And we show the backend pipeline. So the generation status and events show processing progress. And we have shown CAD outputs, so the system can produce downloadable CAD artifacts. And we have shown modular architecture. So we have the front end, back end, AI provider, and the runners. All of them are separatable. And also we have shown the honest scope of this one. So we have shown the current limitation and also the roadmap for the future. All these are disclosed. From design intent to editable CAD artifacts. We hope this text-to-3D platform could help you make your ideas come prototype design faster, and we welcome every suggestion. Thank you.